So what is the blockchain trilemma term? Buter in the blockchain trilemma addresses the challenges that developers face in creating a blockchain that is scalable, decentralized, and secure without compromising on any facet. So if Kadena is the only layer 1 proof of work blockchain in history to solve the blockchain trilemma, does that mean that Kadena will become the one blockchain that'll rule them all? To understand that, we first need to do a deep dive into what is the blockchain trilemma, and we also need to discover what are the current limitations with blockchain technology. And shout out to Doug's Beardley from Kadena. This is going to be a recreation of one of his speeches that he did at DecentralCon Miami. Link will be down in the description. If you guys want to watch the original video, I recommend it. So what is the blockchain trilemma? In order to increase speed, you normally have to sacrifice security or decentralization. You normally have to sacrifice speed or security. No blockchain has been able to achieve all three. They consider it to be the holy trinity of blockchains. So roughly speaking, all single chain layer 1 proof of work blockchains all have the same performance. They all have the same fundamental limitations: the speed of light, the network bandwidth, and then transaction execution times. Roughly speaking, in blockchains like Bitcoin, we have seen 5 taps now. There are some that can do 10, some that can do 15, but I'm going to use 5 in this presentation because it's a general number that a majority of the community agrees upon. So Kadena took a completely different approach to scaling. Kadena created what is called a multi-core blockchain. Just like your computers use multiple cores to process data, Kadena's blockchain uses multiple cores to process transactions. So if you have one blockchain and that one blockchain can process up to 5 transactions per second, to assume that if we had 2 blockchains running side by side and each blockchain could process 5 transactions per second together, combined, they could both process 10 transactions per second. With 3 blockchains running side by side in parallel, you would assume 5 transactions per chain. You could do 15 transactions per second. 5 blockchains, 25 transactions per second. 10 blockchains, 50 transactions per second, etc. Now, this naive approach has 2 challenges. Number 1, 10 separate blockchains would give you 10 separate currencies. And number 2, a 51 attack would become a 5.1 attack. Problem number 1 being, when you are running 10 different blockchains separately that do not share the hash from the previous blockchain, you would then inherently have 10 separate cryptocurrencies. You would also run into the inherent problem that the 51 attack becomes a 5.1 attack because you can attack just one chain and all you need is more than 50 of the hash power on that chain, and that makes charting an unsecure and unacceptable problem. But there is a solution. What if we braided the chains together? Here is what it might look like with 2 chains. Each blockchain includes the hash from the previous block on the previous chain, in addition to the normal blockchains that include the hash from the previous block in the most recent block that's being mined. If you wait for 1 block after your transaction, it would require the attacker to have the full hash power of both chains to do a 51 attack on that block. So what does this mean? Hash braiding allows Kadena to perform trustless cross-chain transfers, yielding a single currency across multiple chains. So the way that you can transfer coins from one chain to the next is you burn them on the current chain, then you submit proof that the coins were burned, then you recreate them on the next chain. But what if we want to connect more than 3 chains? How can we actually scale further? So if we swing back over here and we take a look at this previous diagram, and then if we collapse that previous diagram and we only look at one layer, you can see that both chains here are connected. Now, if you wanted to connect 10 chains together, there are a lot of ways that you could do this. The graph that you're seeing here on the screen is one potential approach. Now, this approach is great because it is the fastest and you are only 1 hop away from the closest chain. And that's great because it gives you the fastest cross-chain transfers, but that would require you to store 9 separate hashes in each individual block, and that's unacceptable because the size requirements will be too large, and if you were going to scale up from there, it would only get worse. So the thing here that saved the day for Kadena is graph theory. Graph theory is an obscure branch of math, and they have been studying the degree diameter problem for decades, and that's exactly what Kadena used to solve this problem. Now here is what it looks like to connect 10 chains together using a graph theory solution. This graph, if you look at it closely, gives you 2 hops to the furthest chain. No 2 nodes are ever more than 2 hops from each other, and it only requires 3 extra hashes per block. So this is a great solution, and this is exactly what Kadena used when they got started, and they launched their blockchain with 10 individual blockchains all braided together. But what if they wanted to scale up farther? Here is what it looks like when you scale up to 20 chains. The only difference between this and the previous graph is that you are now 3 hops away from the farthest chain, but they are still only including 3 extra hashes per block, so the size requirements did not increase. So what does that actually mean? Number 1, that means that you have reasonable size and space requirements to scale, and that now kadena can perform fast cross-chain transfers. But the question you're going to ask is, what about more than 20 chains? And this is where the graph theory solution to the degree diameter problem comes into play. This table shows a summary of the best solutions. If we have 5 hashes and 5 hops, we can get to hundreds of chains. If we have 6 hashes and 6 hops, we can get to thousands of chains. If we have 7 hashes and 7 hops, we can get to tens of thousands of chains. And if we have 8 hashes and 8 hops, we can get to hundreds of thousands of chains. So what does that actually mean? That means that the architecture of the network is no longer the limiting factor. So this is where we've seen so many blockchains come out in the past, each one trying to create their own new consensus algorithm that's going to allow them to scale to meet the demand of global railroad adoption. But at the end of the day, every time one of these networks gets up to about $50 billion market cap, some have got up to 100, the network just goes catastrophic meltdown. Because as they scale up, everything gets exponentially worse, so any problems that they had and the network got congested when they had 50 million users, well, when they get up to 75 million users, those same issues get compounded. If you take a look at the architecture of a sharded blockchain, as you are actually branching off and you're actually sharding off this blockchain each time you shard, because you have a main beacon chain, and to take over the blockchain you need a 51 attack. But if you take that same block and you divide it into multiple chains, each time you divide one of those blockchains, or each time you shard, you then cut your network security in half. So if I have one chain and I need a 51%, but then I shard that network into 10 different chains, what happens is that 51 attack becomes a 5.1 attack, because I only need to get over 51 of the hash power of an individual chain to take over that chain, and each one of your shards is its own unique blockchain with its own set of validators. So here is what kadena's blockchain looks like. This is what it would look like if they scaled up to 50 chains. So if I wanted to go from chain 42, I might have to go into a gas station, come out on chain 8, go into a gas station, come out on chain 15, and then from chain 15, I can get over to chain 28, or whatever the case may be. Certain chains you'll be able to directly connect with just one hop. Other chains, you might be 3 or 4 hops away. And the secret sauce to that is these cross-chain transfers. So all you have to do is tell your wallet where you want to send it to. If you want to go from chain 5 to chain 35 or chain 5000, all you have to do is just tell it what chain you want to go to. It's going to take care of all the burning, all the transferring, all the everything in the background. So you're not even going to see it. So let's take a look at these diagrams one more time, and I'm going to kind of point out a few more things about why I think kadena is going to be that one behemoth layer, one that's going to rule them all. And then we'll wrap it up if we take a look at that same structure, and we see that as it scales, the size requirements get bigger and bigger and bigger. And I want to say that this is why DAG blockchains can only scale to a certain extent, according to Ethereum's creator Vitalik Buterin. So this is one of the biggest downfalls to implementation of sharding in a blockchain, as individual shards cannot communicate with each other. Moreover, the wide geographical spread of the general distribution of the blockchain nodes, there would be no logic to split them with a random approach currently being proposed. Randomly sharding the nodes would require communications to be implemented in a seamless way between the nodes, which is where the Ethereum Foundation ran into its pitfall. There are a ton more articles out there, and you guys can you guys can drop the comments below and say, I don't have any clue what I'm talking about. You guys are probably right on that fact. But do you understand the potential issues with DAGs? It's important to understand how they operate. DAGs are directed graphs with no directed cycles. What this means in practice is that unlike blockchain operations that operate on a vertical architecture, miners process a block, the block gets added to the chain, the miners mine another block, etc. DAGs utilize a horizontal architecture. This allows, as stated above, for transactions to link to transaction scalability through sharding. This is not an optimal solution, as one of the benefits to blockchain is the immutable and ever-present ledger that it keeps to enable DAGs to avoid this necessary deletion. The DAG can be split into different shards. This works along similar lines to sharding in a blockchain. The DAG is split up into a lot of different mini DAGs. Take a simple example. Consider a DAG split into 10 parts. I present a transaction on one strong tip of the 2 shards. Unless there is a node that has sight of both shards, the transaction that I print will validate in each of the 2 shards, thus causing a double spend. And as DAGs scale, this issue becomes more and more prevalent. The more shards, there are the less chance of overlapping shards, but thus the possibility of double spending increases. So long-term viability, at the present time, the only way for DAGs to guarantee against double spend and a 34 attack is with the aid of a centralized authority by Ball. Another DAG has 12 witness nodes, and AOTA has the coordinator. These tools mean that their networks are not censorship resistant, and that should any one of their centralized authorities be compromised, the network would be vulnerable for attack from the centralized state itself. So let's recap that. So we've seen so many projects come out now. Solana proof of history, very interesting, very unique. But they can't seem to scale because every time they start to scale, their network gets DAS attack because of how proof of history works. Then we've seen other blockchains, other DAGs, that have claimed that they are going to quote-unquote scale. But from the research that we do, we understand that DAGs just don't seem to be that solution, because as they scale, the problems get exponentially worse the more that they shard and the more that their network grows. So eventually, blockchains like Phantom Alpha Zero, they should have their limitations, and they're also not really technically a blockchain, they're a DAG, so they're completely different products. And we've seen projects like Ethereum start trying to shard. We've also seen Harmony, that was supposed to have cross-chain sharding communication, done I think in 2020, and then it was also on their roadmap for the end of 2021, and it still hasn't been hit. And Harmony's blockchain is still only processing transactions on one shard because it's all about can those shards cross-chain communicate, and that's where we see Avalanche in their subnets. But if those subnets can't cross-chain communicate, if those subnet shards aren't able to communicate across multiple shards and every shard of ecosystem be able to cross-yard communicate, they can't really scale either. It's nice to be able to spin up a sidechain, but so can anybody. Flux, the spinning up sidechains, any project can spin up a sidechain. But if that sidechain can't communicate with the main chain or the quote-unquote beacon chain, there's going to be issues. But it all boils down to the fact that Kadena's actually figured out how to scale a layer 1 blockchain. So I will leave it at this. If you take a look at a project like Ethereum, would we have a Solana and Avalanche and everything if Ethereum would have been able to scale? If Ethereum could have scaled to meet the demands of global real-world adoption in a secure, safe, and decentralized way, would we have a Solana? Would we have an Avalanche? Would we have? And if you notice, we see all these different projects and all these different ecosystems growing, but eventually you're gonna get to the point where there is one Amazon, right? A majority of people use Walmart, right? I mean, there are different grocery stores, there are different credit cards, and take a look at an iPhone, right? Most people that switch to an iPhone, their iPhone for life, because it delivers everything that you need on a cellular device. An iPhone is a perfect example of exactly what you need, a little bit extra, not quite under, and the quality is just always there. It's like once you switch to Apple products and you start interacting and using Apple, you love Apple. And then if you are a Windows person and you switch over and you love Windows, guess what? You're a Windows person. Now if you're a Linux person, you're never switching, right? And I feel like that's how it is with Kadena. Once people actually migrate over and start using the Kadena ecosystem, if Kadena can deliver on all of the services and they make it super easy and user-friendly, I think that'll be the most important part, is how easy do they make it for users to interact with their ecosystem. The wallet should be flawless, the community service should be flawless, the scalability, the teams, the everything, and so far Kadena is doing it all right. It might be a little bit slower than we like it, might be hitting some road bumps and some hiccups with Cadex and some issues there, but outside of that, once their ecosystem starts to grow, it's going to be hard to stop them, because to stop them, you would have to add higher superior value, and to do that, you would have to rewrite your own coding language. You had to put together a team like the Kadena team with Will and Stuart Habert, and Emily and Doug, like the Kadena team. I don't think you guys really realize how smart and how much talent they have on their team. Maybe small right now, but I guarantee you they're going to continue to do things right and keep pushing forward, and it's going to be one of those projects you look back on and go, wow, that one play could have changed my life. That's just how I look at it. But you guys do your own research. Tell me what you guys think. Drop some comments below. Love you guys. Shout out to Dogs Beerly, guys. Make sure you guys go check out Doug's original video, because I really copied exactly what he was saying. I added a few things myself, but a majority of that was from him. So I don't want to take any credit or anybody to say anything. That's all Doug. Love you guys. I feel like I'm falling peace birdies. Back, tell me I'm garbage. I'm going through something, that's why I ain't calling. Thanks for watching.